Hi, everyone. Thanks for joining and welcome to the UXL oneAPI webinar. This is series of webinar we are planning as part of UXL every quarter, and you will learn about different technologies from oneMCC to the open source SIG, what is happening on the AI side, uh, and on the other marketing to the Dev Summit, which we are planning. So I'm Manoj Sabrawal, working on the AI infrastructure at Qualcomm, and today we have Verena and Peter from Qualcomm who are working on the GPU and CPU, and we will be presenting on the UXL, how Qualcomm is participating in the UXL Foundation and why it's important, right? And this session is about open cross-architecture compute. So over the next 40 minutes or so, we will want to answer three practical questions. Why accelerator software is getting harder, not easier? What does oneAPI actually standardize? And why does Qualcomm believe in open approach uh, for the developers and the ecosystem? And what we are doing with oneAPI. We'll start by grounding ourselves in the problem, fragmentation in today's accelerator landscape. Then we will introduce UXL and oneAPI and how they address that problem. We'll explain why Qualcomm participates in this oneAPI, how we are using this APIs mapping to our CPU and the GPU. Finally, we'll touch on one construction toolkit, upcoming oneMCC. We will have a next future webinar session on oneMCC or memory compute, and we'll close with Q&A. At Qualcomm, innovation spans edge devices, as you know, automotive, PC, they are XR, cloud, all different devices, different form factor. Each environment has different constraints. Some needs very low power, latency, some has memory requirements, and the cost. And what we have learned is, yet developers increasingly want to reuse the same framework and code across all of them. And the challenge isn't about what we have learned about hardware capability, it's a software portability across heterogeneous platform. So the same software software API developer wants to write on the cloud, also on the edge, and in edge also there are many different edge-based systems from IoT to XR, mobile, and the PC. They want to reuse it, and that's the challenge we think, where oneAPI and UXL helps us for bringing software portability across heterogeneous platform. So I'll quickly go over Qualcomm AI stack. Qualcomm platform are inherently heterogeneous by design. So CPU, GPU, NPU are working together within the same system. And we also, our accelerators are spanning, again, as in the previous slide, from a very small form factor to the cloud base, right? So as we all know, real workloads are not exactly mapped on the single engine. They are scheduled or orchestrated across multiple compute blocks. Our AI stack spans orchestration, runtime, system software, enabling that coordinate across the SoC. Now, importantly, this stack is not meant to be the closed system. The goal is to design to integrate with open standard and upstream ecosystem, not to replace them. So, and that's become critical for the developer who don't want to write framework or learn vendor-specific API for their platform. And this is where oneAPI, UXL oneAPI fits naturally, because we are able to ingest these industry standard open framework into our stack. So oneAPI sits above the hardware specific implementation as a common abstract layer, library, and programming. It allows the developers to target our heterogeneous systems using standard API while we are working to optimize our own specific vendor specific frameworks like QNN or CART SDK, which we call Qualcomm Genie SDK for the AI stuff, or any of the open standard with the oneNX runtime or LightRT. So for Qualcomm, this becomes a key because as you learned from previous two slides, Qualcomm supports multiple operating system and the form factor. Now, and the real world workloads, as we discussed, don't run on the single compute engine. They span across different IP, CPU, GPU, and NPU. Now, on the right-hand side, this is where the UXL comes into picture. One open source frameworks and libraries are how developers scaling today. And oneAPI enables that reuse of the investment across heterogeneous platforms. So it's more like write once, run everywhere. It helps us to scale on multiple more platform and need more developers. So I'll start with the complexity and how we are using UXL mapping on the CPU, GPU side and the construction toolkit. So today, each accelerator, as we know, are vendor exposed. So they are running on different programming stacks. Few of them are very CUDA specific, Metal, and then vendor SDK. So each of them has its own API tools, assumption, and developers are focused to choose early and rewrite whichever works best for them. But this creates a long-term friction and not just for short-term inconvenience that they have to use this programming language, right? And what we would like to see is how we can improve developer experience moving from Qualcomm device to any other device or bringing other the developers has written the software for the other IPs to Qualcomm devices. And this is where we think why Qualcomm wants to participate in the oneAPI. One is the fragmentation. It leads to more porting, more plumbing, and of course, developers will prefer one over another IP, right? Developers are spending more time adopting to hardware than improving the algorithm. And what it happens is Qualcomm built the platform for multiple compute engine. Now they get to port that external software to our own software, this becomes a big bottleneck. What oneAPI, UXL oneAPI gave us the way to reduce fragmentation without introducing proprietary locking. That's very important, and developers are looking for that. Enable a single open programming and library model across CPU, GPU, and NPU. Allow our vendors to differentiate on performance below these APIs. So it's not more on the software fragmentation. And that means for Qualcomm, oneAPI is about ecosystem scale. We can reuse a lot of work already done by the ecosystem and long-term sustainability. So where UXL help us is, and we think it will help developers. One of the important stuff is vendor neutral foundation, not specific driven by one IHV or company under the Linux Foundation. It governs the oneAPI specification and related initiatives. Also, as we know, UXL oneAPI, it's open spec. Everyone here who can contribute to the open spec. Also, open source reference implementation. We are improving the conformance and certification test as part of the steering and the SIG groups led by many of I see here who are attending. But the goal is to simplify but important write once and deploy for any architecture. Now, I'll just go over quickly about the overall oneAPI standard, and then I'll jump into where Qualcomm is using not every of these blocks, but the most important stuff is oneAPI defined one specification with many implementation, right? It spans AI, threading, journal routines, memory-centric compute, which is just added last Q4, and we are working to improve that this year, part of oneMCC driven by Samsung. So the goal here is any application in different domain, you can use these libraries for reusing the libraries for implementation or bringing to our own devices. Now, where Qualcomm is putting our participating focuses, not all the libraries, but one is the oneMath library for other different kind of implementation from algebra to vector math, and Peter will go over how that maps to ARM ecosystem and Qualcomm architecture ecosystem. Then reusing some of the one DNN where we are focusing on both again CPU, GPU, and accelerator side. On the one DNN side, what are leverage we are leveraging and how we are improving our architecture or leveraging our architecture ISA for these matrix multiplication activation. And the last one is the one MCC. Again, this is very early, but we are not looking one APIs just for the HPC AI software side, but also expanding to different domain, including in-memory compute, which is very important for the AI, especially with the LLMs. So with that, I will hand over to Peter on how we are using one API at Qualcomm and how we are mapping this CPU functionality on and what advantage we think to the ecosystem and of course to Qualcomm.
Yeah, thanks, Manoj. Okay, thanks for switching to the next slide. Yeah, so my name is Peter. I'm in the CPU compiler team here at Qualcomm. We work on various compiler frameworks and infrastructure and libraries and so on. We took a look at oneAPI and explored where we would be able to make the most impact from oneAPI with the contributions from Qualcomm. And I've highlighted three things here. Manoj already touched upon these. That's SYCL, of course, oneDNN and oneMath. What I wanted to highlight with this slide as well was that this is not only relevant for Linux/Android. This is also relevant for Windows for us as well, since we are creating compute in the laptop space as well. This is not dissimilar to the work we are already doing in the other spaces of libraries. For instance, we've done work in upstreaming in the context of Kleidi AI and XNMPack. So this is kind of down the same path of library work that we want to continue working on to enable the oneAPI community as well. Yeah, so let's move on to the next slide, Manoj. Okay, so let's take a look at oneMath first and how that's relevant for Qualcomm. So as you all know, oneMath is a vendor-neutral library that can be used in context of SYCL. That's optimized for both CPU and GPU, so we want to leverage that as well. You have functionalities here, typical functionality you find in BLAST and DFT and so on. But what is interesting to us is to understand where these things can have an impact. So for instance, you see oneMath being used in Llama CPP and Onyx runtime as a optional provider backend for Onyx runtime. But also in other ARM specific backends like the Netlib Flatpak, ARM OpenRNG, and the ARM performance libraries. So you have the option there of using oneMath as a backend as well. So that's where we see the impact and scale possibility for any contributions we do to oneMath. So that's relevant to us. Yes, move on to the next one, Anuj. To summarize why this matters for CPU, Qualcomm specific CPU context as well, is that we are able to leverage just one single API across not only CPU but also GPU that Verena will talk about here in a little bit. But doing that, we can just write once and reuse across all systems. We can also rely on deterministic execution, easier debugging, continuous integration, and so on, and portable performance in standard C++ through SYCL as well. This matters to Qualcomm because we want already oneAPI libraries support ARM64 CPUs, but we want to extend that further to make sure that they are fully optimized for Qualcomm specific ARM variants of ARM64 CPUs as well. And we want our ISVs to reuse the existing oneAPI and also fully be able to leverage that through oneAPI on top of Qualcomm hardware platforms. We can also use CPU as an orchestration engine here. So this is not only relevant for CPU-only workloads, this is relevant for workloads where CPU is the engine that orchestrates and manages workloads that runs on GPU or NPU. And of course, one of the benefits here, why it matters to Qualcomm, is that it's an open standard and as an alternative for our vendors to build solutions to. So that's what I had. I'll leave it to Verena to continue on the GPU side.
Yes, hi, I'm Verena, and I'm evaluating SYCL on the GPU here at Qualcomm. So SYCL is the programming model that is the foundation of the oneAPI libraries and enables it to run on the GPU. And SYCL is an open standard that is defined by the Kronos group, and therefore it is totally vendor agnostic. There are already several open source implementations of SYCL that an implementer can leverage. And there's also a ready-made ecosystem that has been gaining momentum, driven so far by mostly HPC and AI workloads. And the UXL Foundation obviously plays a big part in that ecosystem, but there are also many other elements of that ecosystem, which includes, for example, learning resources. So there's lots of classes and courses already out there, which enable us to quickly train up colleagues as well as customers. There's also research efforts underway to evaluate, to provide independent analysis of performance and things like that. And they also often result in actual improvements of the standard. There's also several tools available out there for people to help them writing and analyzing SYCL and optimizing their SYCL. And of course, these days there is AI, and because it's been trained on everything that's freely available on the web, it can help you write and optimize SYCL from the get-go. And these are all benefits that you would not get if you made your customers use some custom API that you came up with to program your specific GPU. Next slide. And another big part of the SYCL ecosystem is that there's already several open source applications out there that have a SYCL backend. So there's, for example, the Cycles renderer of Blender, which renders 3D objects on the GPU. Or there's GROMACS, which does molecular dynamics, and various other ones to do hydrodynamics, computational fluid dynamics, particle physics, that kind of thing. And there's also several frameworks and libraries that have SYCL backends already. So there's things like Cocos, Llamas, CPP, and TensorFlow. And these are used by yet other end user applications to accelerate them using SYCL. And then beneath those are the oneAPI libraries, which provide the lowest level of SYCL support, which are then in turn used by the frameworks and libraries, which are used by the end user applications. So the premise here is essentially if you implement SYCL, then you can very quickly, almost for free, accelerate all these end user applications for your customers without having to spend years porting them all individually to your GPU with very, very specific constructs. Next. So the developers, so that's the end developers that are writing actual SYCL source code, but there's also the developers of all of these libraries and end user applications. They like SYCL because it is a single source programming model. So the compiler will help you to match up the interface between the device code and the host code. and therefore catch a lot of the mistakes that happen because in other programming models where you have to write them separately and you make different assumptions. It's all standard C++ as well, so there's no need to learn an additional language. This is the language that a lot of people are already familiar with. And it gives you access to the power of templates in your device code, which is really very important for those libraries. Implementing libraries in a generic way requires such a high-level programming model like C++ with its templates. But crucially also for the developers, it is important that SYCL is vendor agnostic. So by implementing a single SYCL backend, you can target all sorts of accelerators in one fell swoop. So that makes it much more attractive for application developers to use SYCL rather than maybe vendor-specific APIs. And it's an open standard, so engineers can actually get involved in the development of the standard. And the development of the standard within the Khronos group is all in the open as well. So developers can actually inspect and see what's happening in real time as SYCL develops. And developers can give feedback and actually request features that they would like, and therefore help make the standard better and more useful for them over time. As to why it matters for Qualcomm, well, Qualcomm likes working with a standardized API. It's not controlled by a single vendor, and one that Qualcomm can actively get involved in. SYCL also aligns with upstream LLVM toolchains, and these are widely supported and well maintained and already in use. And it promises to be a single API with which, in theory, you can target the whole of the SoC with a single methodology. So from one application, you can write, from one application, you can write code to target and make use of the whole of your chip, everything that it has to offer. And finally, last but not least, Qualcomm would like to benefit from an existing ecosystem. That means that everything is already out there. People know how to write code for this paradigm, and code is already out there that uses it. It's already made, which is something that you wouldn't get if you designed your own language, your brand new language that only worked for your own GPU. Yeah, on that, back to Manoush.
Yeah, thanks, Verena. Okay, I'll go over quickly on one construction toolkit. So one construction toolkit, it's one of the biggest challenge today is building a software stack for a new chip, right, or an accelerator from the scratch. And what we understand is it can take months to a year of effort and the cost. And this is where we have played with one API, construction toolkit in the past to build using pre-built framework that our hardware like SYCL we went over, and even the oneMath we were able to leverage with the LLVM compiler and all to run on our architecture. So what it provides is a performance critical building block under these oneMath, oneDNN, oneTBB, all these libraries, and you already see where we are investing using oneDNN, oneMath, and of course the SYCL side of it, where we are especially around AI and pre-processing pipeline, like for BLAS, we have upstream our hardware-specific, CPU-specific instructions to the BLAS library, and now oneMath is able to also leverage that, similar for the oneDNN side. So again, the goal of using one construction toolkit library is using this building block and leverage the backend map to our LLVM or SYCL compiler side and use our hardware backend. it also has other libraries which we are not right now leveraging, like oneTPP, oneCCL, and DAL, more around the analytical and classical ML side, or communication or CPU task parallelism. We use other libraries, but oneMath and oneDNN does help us to scale, bringing these new use cases very quickly, because it's a backend plugin, and it unlocks the framework compatibility very easily. So what we have done, and we can share more information. We have last year we did demo on bringing this one construction toolkit. We implemented a simple plugin. Again, as I said, it's using the LLVM based compiler, which has been already upstream, and then mapping it to our backend library. So oneDNN we used, which has all different architecture backend already support. And then we use those primitives, instruction set running on our Qualcomm specific architecture. And this was we were able to run oneAPI UXL very easily to our hardware and giving good performance at the same time. So again, the goal of using construction toolkit is, if we don't want to start from how we can bring these blocks to Qualcomm, or if as a developer you want to see is how you can leverage these building blocks, one construction toolkit is the very simple way to start that process. It's a backend plugin kind stuff, and it reduces the duplication and acceleration to enable ecosystem, any of the application. So I'll now touch on oneMCC. Again, this is very early, but memory-centric compute is getting more and more important. So traditionally, computing is hitting, especially with the AI side, is hitting memory wall, right? Moving data from processor and memory is too slow, and also power hungry for these massive AI models. So last year, we at UXL, we working with many other vendors, including Samsung, Micron, SK. We start defining, and Intel included, defining this oneMCC spec. The goal was to leverage UXL Foundation, and that will help us from Qualcomm side leverage these new APIs where in-memory compute can be also leveraged right there. So we are defined, oneMCC is currently getting defined, spec has been written. Samsung is leading. We are contributing with other vendors on improving this oneAPI spec. The focus is it's open, right? So it's retargetable compiler and runtime abstraction. So it helps us to bring different languages, and of course this oneMCC connected with all this goodness of the UXL running on different frameworks, and it can leverage on our CPU, GPU, and the NPU accelerator. Now, one of the important part which we are contributing, as I already discussed, part of one construction toolkit is improving LLVM compiler to leverage our instructions. We are adding, for NPU side, have added also LLVM based specific changes. So we can leverage those and improve map to in-memory compute use cases. So, but again, what this new specification will provide us is foundation where we can, not just for the HPC or AI for running the compute, but expanding. UXL is helping Qualcomm to expand into new technology for in-memory compute also. And we do plan from UXL steering committee side is next quarter or in next 6 months, one of the webinar getting more deep dive from Samsung on oneMCC. So I want to end is how this fits for Qualcomm and of course for the ecosystem. The frameworks application, they continue to be getting evolved, and what developer wants is scalability, and what every vendors also want is to bring quickly those application to getting best from the hardware, right? And this is where UXL oneAPI is helping Qualcomm. We are leveraging one DNN, one math. We are exploring other uh, initiative APIs also, and of course, as Verena went over, Chronos based SQL is also helping us to bring new use cases or to our Qualcomm hardware. And then, of course, the oneAPI runtime, where we are leveraging all the device scheduling capability, but ecosystem vendors can also leverage that for moving the application from one vendor to another vendor. Stuff don't have to be tied to one specific API. And at the end, for us, CPU, GPU, NPU, and now one MCC becomes very important because that's where we can scale for new use cases for AI, and of course, the pre-post processing optimization, which are getting into the compiler side, uh, running on our hardware. So, and this UXL has helped Qualcomm to at least get started quickly instead of starting from the scratch. We want to get everyone's your feedback and also join UXL steering committee general member to make sure you influence the spec, make the changes, and we also expanding it to different, I think, SIG groups. We are adding more on scientific AI side as part of the UXL Foundation to the AI SIG, so we can leverage new use cases on oneAPI UXL. Okay, we are open for Q&A. And let me see if there's any offline chat.
He just asked, is Jack support on the roadmap?
Oh, so the question is how Qualcomm roadmap on this UXL?
List of frameworks you listed. You have PyTorch, TensorFlow, but not Jax.
So so the goal here was not to share a overall roadmap, but we are bringing as many new industry standard frameworks on to Qualcomm stack. Either we will be leveraging the UXL or like the second, third slide, Qualcomm proprietary stack for those industry standard framework. Any other questions?
So, Jeremy Bennett here. I just put a question on the chat. From your experience, how small an architecture do you think you could get oneAPI to work on? Would it go down does it have to be an application class 64-bit processor? Could you put it down into a larger microcontroller? Do you need a full operating system like Linux, or could you go down to a machine running an RTOS or even bare metal? I'm just because we tend to work more on that size of machine. I'm just interested as to how small you think it's feasible to port everything.
So right now for the UXL oneAPI side from Qualcomm perspective, we have not tried on that low end. The part which we are looking is more, I'd say, IoT to mobiles to the data center side, leveraging that. So yeah, we have not looked at that low-end microcontrollers yet running these UXL workloads. Peter or Vanina, you want to add anything?
Yeah, I would say at the moment that I'm not aware of any SQL implementation that would run on something that has no operating system or very bare bones operating system. So there'll be some work involved in, writing a runtime for SYCL that would run on such a small device. So it would be challenging starting from scratch, but it would be very interesting, certainly.
Okay, thank you very much.
I have a question from the application developer side. So, are there any timeline on when the SYCL implementation is gonna get in the hands of end users and application developers? Because upcoming, say, consumer devices like this next gen laptop SoCs, that for us, the growing developers, is interesting target. It's not a priority, but it's definitely interesting because people will be using that.
Yeah,
So
unfortunately,
are you planning to have like day one support or a little bit more delayed? Yeah, sorry.
Yeah, we don't have a concrete date that we could share right now. So we'll have to evaluate and see how to see what makes sense, really.
But so you're not currently aiming at like day one support or this kind of.
At the moment, there's nothing. No, there's nothing. No support out there on existing Qualcomm chips.
Okay, so there is no way to try and like benchmark it on.
No, unfortunately, no.
Okay, I see. Thanks.
Yeah, I see other questions on x86 oneAPI. If Qualcomm is using it, should I consider it ready for ARM processor? So I'll let Peter chime in, but we do support. oneAPI do support multiple backends. One was the CLIDE side or ARM compute library. The architecture it runs actually on Qualcomm chips also. Peter, you want to add anything there?
Yeah, earlier I listed a few things related to oneMath specifically, right? So there's already quite high level of support for ARM already, and integration via frameworks like ARM performance libraries. So and even in higher level, even Llama CP, for instance, or Onyx runtime. So you can you can leverage ARM today already through oneMath already today. And this is what we're going to continue looking at and optimize further from Qualcomm side.
Varina, you want to answer that? What is the low-level driver API with SYCL maps to?
Yes. Well, I mean, level 0 is Intel specific, and CUDA obviously is NVIDIA and HIP is AMD, but SYCL historically mostly and still is supported on OpenCL, and Qualcomm actually has an existing OpenCL implementation that's released, so that would be our natural target.
I think there's one more question I can answer. oneAPI use in automotive right now, not directly. The goal of this was to show how we are right now exploring across different IPs, but there's no roadmap plan on the automotive side. There was I think last year, as part of UXL, not Qualcomm, AutoWare. I think that was evaluating the UXL side, but right now from Qualcomm specific, no. Right now we are not using oneAPI. And it's risk fine on the roadmap. Again, I will talk from the UXL oneAPI math. I don't know if John is here from the SIG side, but there's multiple, the architecture is already supported in oneAPI on UXL, and risk is part of that. So I think it's very early in oneAPI stack. Ecosystem is contributing, and we would like also contribution from to UXL. So yes, there is support for risk. I think we can get back on the roadmap, both from Qualcomm and the UXL side, on the risk implementation. But UXL do have some early prototypes from community. Yeah, we are on time. No other questions. I think we can. Yeah, thanks for joining, everyone.
Thank you, guys. It's been great.
Thanks, Melissa. If you're still there, yeah.
Thank you
And
so
thanks.
much.
Thanks, everyone. We will, I guess, issue out the recording link. Keep an eye out for that. And yeah, that's it. Please visit our website. That's also being updated very soon. And yeah, please keep an eye out for the newsletters. Thank you.
Thanks.
Thank you.